Does the tie go under the jersey or over the jersey? It's been a long time since I played.
Everybody get up, it's time to slam now. We got the real jam going down. Welcome to the Space Jam. Here's your chance, do your dance at the Space Jam. Alright.
Wait, where did he go? Oh, I guess that's his thing. What is up, Glenwood Middle School? Welcome to day 13 of online learning. Congratulations, you've gotten this far. We're going to keep going further. Today we will be talking about arithmetic and geometric means. Hopefully I am able to teach it just a little bit better. So an arithmetic mean is we have an arithmetic sequence, meaning it's got a common difference, right? Adding or subtracting the same thing. And what we're always looking for in the mean is the middle number, right? So in this case, 2 and 12, we would plug it into the equation a plus b divided by 2 equals our arithmetic mean. 2 plus 12 is 14. 14 divided by 2 is 7. So 7 goes right here. Let's say we have a longer pattern and we don't know all of the steps, right? So if we are going from 2 all the way up to 12, we need to get 10 bigger, right? So we're going to do 12 minus 2 this time, right? And we're going to figure out our common ratio so we can add it. So 12 minus 2 is 10. And then now we need to figure out how much we need to divide by. And we're going to divide by the number of blank spaces, right? Or sorry, the number of steps to get from 2 to 12. So step 1 would be 2 to this guy. Step 2 would be 2 to the next. 3, 4, and 5. So we have 10 divided by 5. This will give us our common ratio of, common difference of 2. So when we plug in and we add 2, 2 plus 2 is 4, 6, 8, 10, and 12. And that's how you would do it for an arithmetic mean. Moving on to a geometric mean. Once again, our equation for a geometric mean is the square root of AB. So the first number times the last number, and you take the square root. So let's start with a 2 and a 32. Now, let's make it easy for Mr. Cartwright. Let's choose a 2, and then we would have a blank in the middle. And the last number that we're going to use is let's use 32. All right. So we have 2 and 32. If we're going to multiply those two guys together, 2 times 32 would be 64. And we take the square root of 64 to get 8. Our geometric mean in this case is 8. We can then find our common difference by placing the 8 value over the 2. And in other words, we're multiplying by 4 every time. So we can find the number in between, the middle number of a geometric sequence, by taking the first and the last number and taking their square root. Now let's go on to a harder one. Let's say we have this sequence 4 blank, 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 972. What we're going to do is we're going to set up an equation. This is going to be, and it's going to be based on our, the equation that we always use, right? So if we have f of n here, right, that's going to equal the step before, right? And since this is a geometric sequence, we are going to multiply that times the rate raised to the x power. So we're going to get rid of this guy. This guy is actually our a value, right? A times r to the x. We are using our YAR equation like always. And now we need to figure out how many steps, right? So how many steps do we have between 4 and 972? We have 1 step, 2 steps, 3 steps, 4 steps, and 5 steps. So we know our x value is 5. So we have r raised to the 5th power times a, and that equals y, right? We can now plug in our y value. Our y value should be 972, right? Because that's our last value. Now we need to solve for our r. Our a value in this case is where we start, which was 4. So we have 4 times r to the 5th equals 972. Let's divide both sides by 4. 972 divided by 4 gives us 243. And let's find the square root of 243. Mr. Curry is going to do that on a calculator. Mr. Curry made a mistake. Let's take it back a second. So we are not taking the square root of 243, right? We're not taking the square root. We are taking the 5th root of 243. Because we have r to the 5th over here, right? So the 5th root of 253 is going to be a number. It's going to be nice and easy. So the 5th root, and you would have to do this on a scientific calculator, the 5th root of 243 is 3. So 3 times 3 times 3 times 3 times 3. 5 times would equal 243. So we've now determined that our common ratio is 3. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. And 324 times 3 would give us our final answer of 972. So, once again, what we're going to do for a geometric sequence is we are going to plug values into our YAR equation. So, for instance, let's do one more problem together. All right, so let's say we have this geometric sequence right here. 3 blank 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 243. So we're going to be plugging things into our YAR equation. And the first thing we're going to plug in is our a value, which goes in right there for the 3. We have y equals 3 times r. And how many times are we going? 1, 2, 3, 4. So r to the 4th. You agree that if we took 3, we multiplied it by our r value 4 times, we would get 243. So then we know what our y value is too. Our y value in this case is 243 equals 3 times r to the 4th. Okay, next step is divide by 3. We divide 243 by 3, we get 81 equals r to the 4th power. So now we need to take the 4th root of 81. Mr. Card's going to bust out the calculator, and he's just going to ask Google, 4th root of 81, and that is 3. So what we are doing here, r equals 3, and in this case, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3 is 243. So hopefully that all makes sense. What you're going to do when you have a geometric sequence is you're going to count the number of times you have to multiply by r. That's going to go right there, and your starting value is going to go right there. Your final y value should be your final value in the pattern. Hopefully that all made sense, and you guys have a wonderful day, and please return to the live classroom.